Hey folks, welcome to CS Code 28 Honors. For today's lecture, we are exploring two topics, strings in Rust and match statements. First, let's look at strings in Rust. There are broadly two types of string, $str and string with a capital S. The differences for now, the only differences we will look at are the string $str is immutable and the string is mutable, meaning you can actually modify its elements or add strings to it, etc. The differences will be further explained in ownership lecture. And both of these types of string have convenience function to stream, to trim, split them, etc. How to create a string? Well, to create an $str is very simple. We just code around them and assign them to a variable. How to create a capital string? So to create a capital string, there are a couple of ways. We can call string : from and put a string literal in there. We can also do a string literal dot to string to underscore string. We can also create an empty string by just doing string : new. That will create an empty string for you. We can also actually cast an integer to a string by calling integer dot to underscore string, and that will create a actual string containing that integer. How to cast? We can also cast between these two types of string. First, we can cast an $str to a capital string. There are probably two ways to do that. First, we can call dot to underscore string on the $str. It's very similar to how we created a string capital earlier. You can also do string from. It's also very similar to how we created a string capital from earlier. We can also cast a string capital to an $str. How we do that is basically we just call s underscore str on the string capital. That will create a $str with the same value. And there are also more ways to perform these cards that we will cover in future lectures. We can also compose a string capital from other values through the format macro. How this works is very similar to the printline macro. Here you see that we have a hello variable as an $str with the value howdy and a cost number with value 128. We want to create the string howdy saved to 128 on this. So what we do is we just call a format statement with a couple of characters and some placeholder values in there. And the format marker will substitute our two values into these placeholders, and the result will be similar to as if you just call string : from howdy set 128 on this. Next, we will look at match statements. These are expressions that allow you to compare value against a series of patterns and then execute code based on which pattern matches. What is a pattern? They can be literals, they can be variable names, they can be anything. These are similar to switch constructs from other languages, except they're both more powerful and with more strings attached. We will look at from the examples later. Here are two examples of a match statement. In the example on the left, we have a call variable that is a string, capital S, we get from some function. And we call a match statement on this variable. Here you see that we looked at three cases. If the variable is IRL, then we print line INI. We can execute code in this match statement. If the variable is to infinity, we reply with and beyond. If it's Sakuna, we reply with Matata. And lastly, you see this special character here. That is a wildcard character, which broadly means that we don't care about the rest of the values, the other values. And we print a statement that also means the same thing. We know how to respond because we don't care about them. And for example, on the right, we have a cost number variable that we get from some function, also get from some function. And as you can see here, a match statement is similar to an if statement in that it is an expression. That means you can also return the value from it and assign two variables. So here we match on cost, and based on the value of the cost number, we will return an ampersand SCR, which will get assigned to the variable professor. That's what it means by like professor equal to match, equal to this match. Here, if it's 134, we return Prof. Shalan. Is 128, we return Prof. Novak, etc. And you also see we use a wildcard character here. Therefore, that means for the other classes, we don't know who the professor is. A couple of things to note here. Integers, in our case, are 32 here, and ampersand SCR are both patterns. Whereas a string capital is not, as you can see from the example on the left, we have to call s underscore SCR on string to actually be able to match it. The reason will be explained in a later lecture. And you also note that match statements are expressions, as we have emphasized, meaning it can also return a value, just like an if statement. And you also note the use of the wildcard here. A couple of rules on matches. First, the patterns must be exhaustive. The match arms, that means the cases we have seen, must cover all possibilities associated with the data type. So that means, for example, we have an I32. That means we must cover somehow all 2 to 32 possible values of that data type. But then how do we actually do that? That's so many values. And that's where the wildcard come into play. Sometimes it's very hard or impossible to cover all possibilities. For example, with I32, we've seen earlier. So here we use a wildcard. It basically means the remaining patterns. In CD Parsec, we don't really care about matching a specific part of the data type. Here, in the case of I2, it means that we don't care about the values aside from those we already match. So let's look at this example from earlier. Here we only care for about 4 classes: 124, 128, for 173, and 225. And for all the other classes like 233, 341, 374, we just represent them with a wildcard. That means the rest of the values, and I don't care about them. I don't know who that is, who the professor is. Let's look at a practical example. So what you are looking at here is basically the example from earlier. We get a get cost number function that basically returns a random element from these 6 CS classes. And then we match the course number and get the professor name. And finally, we print both the course number and professor name out. So let's look at a couple possible runs. Here, our class number is 233. And so since 233 does not appear in one of our cases, we don't know who that is. That means it belongs to the wildcard case here. Oh, here we get CS128. We don't know who that is, since it is one of the cases. So we know that the professor is Professor Novak. And 341, we don't know who the class or who the professor is. So it is a wildcard cases. It's not one of the 4 cases. So again, I don't know who that is. 233 again, 225. Here is one of the cases, and we know it's Professor Evans. So yeah, that's basically how an example on how match statement works. Structuring. This is an advanced use case of a match statement. So if a type can be decomposed, such as a tuple, struct, or enum, the latter two we will look at in future lectures, we can match on all or specific parts of the types. Wildcards also come into use here, as we will see later. We also use a range notation, that is this double dot, to indicate that we don't care about the portion that the range covers within the data type. We can also bind variables to values in the match statement to continue using them. And variables here basically act like wildcards. Let's look at an actual example. Here we see have a triple, that is a variable of a tuple of 3 identities that we get from some function. Here we will attempt a match on that variable. The first case, we're going to check if the elements are in order 1, 2, and 3. So that is a case we only know all the values. For the second case, we just want to know if the values n in 2 and 3. And the first value can be anything. Do note here, since we already covered the case 1, 2, and 3, the wildcard here will not match to 1. So basically, second case here covers possibilities like 0, 2, and 3, 2, 2, and 3, 3, 3, and 3, 3, 2, and 3, but it will not cover 1, 2, and 3, which we will already cover in the first case. So if you have 1, 2, and 3, we go to the first case. If you have 2, 2, and 3, it will go to the second case. For third case, again, it's very similar to the second. We only care if the first two values are 199, 128, and we have the wildcard here. Since the 199, 128 button hasn't appeared anywhere, the wildcard can be anything. It can be 0, it can be 1, it can be 2, 3, 4, 5, it can be any i32 value. Next, here is an example of the range notation. Here we only basically what we mean here is that we only care if the first item is 128. The range notation means the last two elements and we don't care about them. And similarly, here we only care if the last item is 2024 and we don't care about the first two items, whatever they are. And the next case is an example of variable binding. Here, what this means is that similar to the wildcard, we only care if last two elements are 1 and 1, except the item that we don't care about, we also assign them to a variable named A. So here, this case can match to anything, 0, 1, 1, 1, 1, 1, 2, 1, 1, anything. And we assign the first value to A. And we can actually use that variable. Here we print out A in this string, got A and 2, 1. So if it's 1, if it's 1, 1, 1, then we print out got 1 and 2 ones. And for the last case here, we can actually use a variable binding on all three items. So it's very similar if we got a wildcard on all three. And we can also use them. We use them to add them together and then print the sum out. For example, if we get 5, 4, 3, then we will print out triple as to 12. Do note that this cannot cover some of the cases we already seen from earlier. So X, Y, Z cannot be 1, 2, 3 in order. Similarly, Y and Z cannot be 2 and 3, since that case we already seen. Or X and Y cannot be 199 and 128. X cannot be 128 by itself. And Z cannot be 2024, since that's all the cases we already covered. So yeah, here you can see example of destructuring a data type and example of how matches must be exhaustive and exclusive. So yeah, that's basically an introduction to strings and matching. For the next lecture, we will continue exploring matching and the new data type called enums.